Very warm welcome to the members from Miwon Speciality Chemicals, India as well as South Korea to have visited our institute. We are very happy and we give a very warm welcome to all of you. We are also joined by our faculty members, our students, senior year students in this session here today. But as you are already aware about the schedule of the session, so pre-lunch there are two sessions. The first one will be delivered by me, and the second one will be delivered by Mr. Bhattacharya. Following that, we'll break for lunch, and the practical lab demonstrations. One will be here itself, and the other two in our machine workshops on the ground floor. That will be delivered by our instructors from the department. So I will introduce one by one. First, I will introduce the faculty members who we have here today, starting with Mr. Boroprasad Mondol. He is the principal in charge and lecturer in our institute. He has a Master of Engineering degree from IIEST, formerly Bengal Engineering and Science University, Shibpur. He has joined our institute as the principal in charge, and his wide experience spans more than 3 decades in our polytechnic system. We also have with us Mr. Parthu Mondol, who is the Secretary of Academic Council and lecturer in Computer Science and Technology at our institute. He is also a very senior faculty member, and his experience spans also 3 decades in this system. Then we have our former head of the department and lecturer in printing technology, Mr. Krishnendu Haldar, who is a faculty member in our institute. We also have Mr. Miwon, lecturer in computer science and technology in this institute. We have senior instructors in the Department of Printing Technology, Mr. Soumitra Majumdar. He is in the DTP and the T-Press section. Mr. Ujjwal Machi, another senior instructor in our department. We will also be joined by another faculty member, Mr. Namto Mishra Menombai. So, without any further ado, I think we are the right time to start this August gathering here. But before we start, let us formally introduce our very honored guests that we have here with us today. From Miwon Speciality Chemicals India Private Limited, we have Mr. Indrajit Bhattacharya, who is a seasoned UV-EV curable coating specialist with a career spanning more than 30 years, which he began with Asian Paints and then advancing into UV technology at UCPSA in 1994. His global journey includes advanced technical development in Belgium, a European patent for UV inkjet inks in 2002, and influential work promoting UV and EV technologies across the Asia Pacific region. Since 2017, he has led Miwon Speciality Chemical India as local director and authorized signatory, while overseeing technical service and business development across South Asia Pacific, the Middle East and Africa. A recognized thought leader, he has presented at major industry conferences and published extensively in journals like APCJ, PPCJ and Paint India. He holds a master's degree in science management from Boston University and postgraduate qualifications in paint technology from VJTI, Mumbai. A very warm welcome and a big round of applause for Mr. Bhattacharya. With this, I also request our principal in charge, sir, to kindly felicitate Mr. Bhattacharya at this beginning of the August gathering, sir. Appreciation also from Mr. Bhattacharya. Welcome to our institute. Next, we are very happy to also welcome Mr. Yong Chin Lee, who is a member of the R&D team at Miwon Speciality Chemical, South Korea. At Miwon, he has been responsible for testing UV LED oligomers and monomers and developing technical literature based on experimental data. He has experience in product synthesis, product evaluation, and formulation guidance. We are very happy to have you here among us, Mr. Lee. So kindly requesting sir to please felicitate Mr. Lee. Please. Very warm round of applause. Then we have another member from Miwon India team, Mr. Sharnashish Mukherjee, who is a technical service and product development manager at Miwon Speciality Chemical India. He is responsible for oligomer testing and developments of products based on UV LED offset, wave offset, reflexo, radio, along with some industrial experience and application portfolios. Previously, he has experience over 11 years in working with recipients. But most importantly, we grew up together. He is my childhood friend.
13 years.
13 years. We have studied together in the same school. We grew up together, went to the same places. Even to work, we were together in DIC Delimited when I was there in the assignment. Very warm welcome to Sharnashish as well.
Thanks.
Then we have Mr. Satish Purat, who is a technical service and development professional with over 14 years of expertise in graphic arts, printing inks, spanning water-based UV LED and dimensional systems. His experience covers the full spectrum of R&D, product formulation, in-plant operations, quality control and technical service. Mr. Purat brings valuable international exposure from his role in Nairobi, Kenya from 2014 to 19, where he served as QC and R&D assistant manager for a leading manufacturer. From 2019 to 2025, he strengthened his leadership credentials as technical manager at Quality Industries, Mumbai, overseeing R&D developments. He is currently contributing as the technical service development assistant manager at Miwon Speciality Chemicals India Private Limited. Very warm welcome to all of you to be present here and gracing this August ceremony. So without any further ado, I think we are right on time to begin this journey here that we have here today. So I will be presenting the first session, that is a lecture session where I will be discussing about press performance, printing process insights towards better chemistry. I have divided the agenda into primarily three components, beginning with a brief introduction of our background as well as the printing process. This will be followed by a detailed discussion on the various printing processes that we have, and followed by, in the last section, we'll be discussing about various quality control techniques and some ISO standards related to printing processes. So a little bit about our institute. Our institute was established in the year 1956 under the first 5-year plan of government of India. So this was established by the recommendation of AICT under the Government of India plan as School of Printing. In the year 1980, our institute was taken over by the Government of West Bengal and was named as the Regional Institute of Printing Technology. There were 4 such institutes all across India, which was set up under this first 5-year plan. One in Allahabad, one in Kolkata, our institute, one in Hyderabad, and the other was in Mumbai. So, of all these institutes, today we are the only institute who is run by the state government, respective state government, but all other institutes have stopped taking students from the regional states. But we have continued to take admission of students from all 12 regional states of Eastern India. Now we are offering 3 full-time AICT approved course on diploma in printing technology, multimedia technology and photography, and we are affiliated with the West Bengal State Council for Technical Vocational Education and Skill Development. These are some of the pictures from the very early days, from the starting days. As you can see on the right, the top 4 are from the early days of our institute, and the bottom 2 are more recent pictures. A little bit about me. I am Shankar Devnath. I have a BE and MTech degree in printing engineering, both from Jadavpur University. I have previously worked at DIC India Limited in technical applications specialist role. And in 2017, I have joined this institute as a lecturer in printing technology. I have also some publications in the domain of print process control, metrology, and color appearance, where I deal mostly with providing solutions to print metrology and color appearance problems using AI techniques. In a professional capacity, I am also a member of MSc and CHD 14 of Bureau of Indian Standards and an associate member of Institute of Engineers. So, with this, let us start our discussion here today. Now, if you take a look at this bird's eye view, so to say, of the entire printing process, if you can really divide it into 3 components. On the extreme left, what we have is the pre-press part of the printing process, which is dealing with development of the image carrier. That may be a permanent image carrier or a non-permanent image carrier. I will discuss a little bit about that later on as well. This is followed by the printing process itself. How the printing process is to be done, how it is completed. These are techniques, these are methods which have different processes. Few of the conventional processes which you might be more interested in, I will be discussing here today. And finally, we have the post-press and the finishing operations in the process, which is the last process before it is being distributed to the end user. If you take a look at the image that we have in front of us here, I will be discussing mainly on the processes that is on the left-hand side of this slide. These are processes which uses a conventional or a permanent printing master, right? Where we have some form of image carrier which is permanent, meaning that you do not have a different image of every print. So the first and the only printing master that you have with us will have to be printed on all the different types of substrates that you are going to print on. So here the reproduction will be the same no matter how many copies you print. But on the right hand side, there are these are termed as masterless, or these types of processes do not have a specific printing master, and at every print, for every print, there will be a different output if we want that to happen. So, our discussion here today is primarily related to the left-hand side, which are having a permanent printing master, starting with screen printing. Then we have letterpress or flexography. Although these are 2 different processes, I have bunched them into a single classification, which I will get to a later stage. Then we have lithography followed by gravure. Leaving screen printing beside, when we have the concept of letterpress and flexographic printing, these are essentially your relief processes of printing, whereby the image areas are on the relief, that is, it is raised, that is inked, and when it is transferred to the substrate, then the ink or the image area gets transferred onto our final material. In lithography, it is basically also known as a planographic printing process, because both image as well as non-image areas are on the same plane. Gravure is an example of recessed process, whereby the image areas are recessed, that is, they are etched inside of an image carrier, which is typically a cylinder. When it comes in contact with the substrate, then due to capillary action, the ink comes out of those cells and gets transferred to the substrate.
Again, this is the process for multicolor printing. I will show a practical demonstration of how this is done using some software. But as you know that for any printing process, especially multicolor printing process, there are primarily 4 different image carriers that is required, especially for those processes related to conventional methods. These are the cyan, magenta, yellow, and black separations. So first, what we have, we normally take the image on a negative, that is on a film, from which it is transferred onto the plate. This is a conventional or the analog process. But nowadays, what we have is known as the CTP process, that is computer to plate, whereby the image that is to be etched onto the plate is directly done with the help of a CTP machine onto the plate without the need for a particular film. So from the plate or the cylinder, as the case may be, we have the image on different image carriers, and then when we ink these image carriers and make it in contact with the substrate, then the ink gets transferred from the image carrier to the substrate, and ultimately we get a multicolor printing process. Now comes the question of how to ensure the tonal gradation. That is, for example, as you can see, the image of the cat, this is having some highlight areas, some shadow areas, and mid-tone areas. That is, there is tonal gradation. In a process like gravure or in a process like offset, where the image carrier itself is on a plane, in case of offset, how do we ensure that in tonal gradation there is highlight, there is shadow in the different areas of the image as is required? This process is done with the help of some process known as half toning. The entire image is divided or is kind of filtered into very small components which are known as half tone dots. On the extreme right images, that is on the top and the bottom, as you can see, it is written as AM streaming. The example that I have been given in the AM streaming, this is a typical type of half toning process which is known as amplitude modulation, where, as you can take a look at the image here as well, the half tone dot where I am moving the cursor, you can see the center to center distance between dots, half tone dots, they are same. But what is changing is the size of the dot. So essentially I am changing the amplitude of the dot. So what happens is that whenever I am etching this different size dots onto the plate and ultimately onto the paper, then the amount of ink that is transferred depends upon the size of the dot. So wherever we have a larger size dot, there we have greater quantity of ink, enabling that area becomes a shadow. Wherever we have a smaller size dot, ink will be less on the paper, and thereby the amount of the area will be highlighted. This is one process of printing using a half tone stream. The other process, which is given in the bottom half here, as well as in the right hand side, this is known as frequency modulation. So instead of modulating the size of the dot, we are modulating the number of the dot, right? So that means, essentially, it means the same thing. Whenever we are increasing the number of the dots, instead of the size of the dot, where the center to center distance between the dots are variable, here the amount of ink that will transfer onto the paper from the plate is higher, ensuring that this area becomes shadow, and where the number of dots are less, there the amount of ink will be less, thereby this area will be highlighted. This is a very specific type of dot modulation, which is again an example of frequency modulation, but a little bit randomness is included in it, which is known as, that is why this is known as stochastic spinning, that is pseudo-random spinning. This is the process. So normally what we obtain, a little bit of information here, the dot gain that we have, that is the increase in the size of these dots from the plate and onto the paper, it is higher in case of FM streaming rather than in case of AM streaming. FM streaming is also known as non-periodic streaming because there is no, now the number of dots in unit distance, this is not fixed, that is why it is known as non-periodic streaming. So dot gain, increase in the size of dot in case of FM streaming will be higher than in case of AM streaming. I will give you one example later on when we are talking about quality control. So this is how the process is done. I will give a very brief demo on this in the second half actually. So this is the watt flow. The top image is basically giving a watt flow of the entire raster image processing. This process whereby a continuous flow image that we are seeing here on the screen, this is continuous flow image, is broken down into a combination of dots whereby it can be printed on a plate using a plate or image any other image carrier. This process is known as raster image processing. Normally, earlier we used to have PS based, that is PostScript based workflow. When we didn't have PDF in the early days of Adobe, we used to have PostScript based workflow. But now PDF is very common and it is the widely acceptable form of workflow that we have in these RIPT systems. We start with a design software whereby we create the design. It can be given by the end user, it can be created in the press itself. Then it is given as an output in the form of a PDF. After the PDF is created, we perform various checks whether certain rules are followed within that PDF or not. For example, let us give you a very small example. Whenever we are printing, as I have given the example earlier, we are printing using CMYK inks, right? But now, on the image that we are seeing on the screen, this is basically an RGB image. So, we cannot print using RGB inks. Yes, we can print RGB colors, that is right. But the basic method of printing multicolor chalks is using CMYK. So, we need to ensure that the PDF that we are going for, plate setting, that must not contain the RGB information, color information. So, these various checks are performed in the pre-flight operation. Then the final PDF is generated. It is further edited. It is imposed. That means, so for example, take a look at the size of the slide here. So if I take a print in a A4 sheet, then this I can take this image and print the entire thing in a single sheet, or I can take multiple images of this and arrange them within a single A4 sheet. So this process of arranging multiple images and stepping it up on the single sheet is known as imposition. Because in the press, what happens? We are printing on very large size, let us say 28 by 40 inches of sheet. So in that single sheet, we will have multiple images on the same thing, so that it can be cut down into smaller pieces and then processed further. So this process is known as imposition, whereby multiple images of the same thing is arranged within a sheet, so that they can be, after printing, they can be cut and reprocessed. Following this, they will be sent for screening. Screening, as I have already explained in the earlier slide, is uploading process. Then finally, we will check for the proof, and we can go for taking output on the plate using a CTC. CTC is computer to conventional plate, or CTF also. Earlier we used to have CTF machines, computer to films instead of computer to plates, computer to films. On the bottom half, there is one image that is given here. This is explaining a little bit about the RIPT system, that is raster image processing system. We take the entire video of the PS file, then it is rendered. It is actually in a continuous flow. So they have to be rendered using a screen. So this can be mathematical formulation if you are going for a digital process, or it can be, as I will show you in the second half, it can be an analog process whereby we have a physical screen through which light will be filtered and it will be, the dots will be obtained. So digitally it can be a mathematical function. For example, error diffusion is a very common technique. It's a very primitive but very common technique for frequency modulation. So then we have the last process whereby the bitmap bitmap image is converted into bitmap image. That is the image where the dots are already broken down, whereby each plate will be inking on these particular dot areas. So this is the RIPT process. This can be a little bit better understood with the demo which I will be giving in the second. Now a little bit about the offset printing process. As I have already mentioned, the offset is a plenographic printing process. So what happens is we have a combination of three cylinders. So starting with a plate cylinder, a blanket cylinder, and an impression cylinder. What happens is in the plate cylinder, the plate is an aluminum oxide plate is wound around. The raised areas, these are not raised actually, for demonstration, for explanation they have given. They are on the same plane. The image as well as the non-image, they are on the same plane. But this distinction, then the question can arise that how are they distinguished? If the image and the non-image are on the same plane, they are to be distinguished with the help of a process known as desensitization. But it's a chemical process whereby the non-image areas, that means where there are no dots, they are desensitized towards ink by using some solutions, and the image areas are sensitized towards ink, so that the ink will be applied only to the image areas and not on the non-image areas. So once we have the plate cylinder, a plate wound around the plate cylinder, the plate is actually receiving two things. One is basically the ink from the top, normally from the top of the machine, will show in the lab. Here we have the ink, which is being applied with the help of inking controllers onto the entire plate. And from the bottom normally, what we have is a dampening unit. So the water, it is actually not only water, but water mixed with alcohol and dampening solution, few other surfactants are there. That is applied on the plate. The interesting part, which is this is actually you can say the beauty and the problem for offset process, is that this creates a major problem for ink makers. That is, they have to work with, when they are creating the ink, they have to keep this in mind. That is, they are working with an ink water emulsion. Why? Because ink is coming on the surface, water is coming on, dampening solution is coming on the surface. They are being applied on the same surface. Well, then there is no physical way of distribution between them. What happens inside is, in the image areas, there is water in ink emulsion. In the image areas, where the amount of water is less and the ink is high. That means the ink becomes dispersed phase, and water becomes dispersed phase, and the ink becomes dispersed medium. But in the non-image areas, it is just the reverse. So if this balance is gone, then there will be a lot of problem after inking. The quality will be degraded. So that is one area that the ink makers have to be very careful, not only in manufacturers, but the dampening solution makers, chemical solution makers as well. Once we have this distinction, that is ink is falling only on the image areas of the plate, then it is in contact with the blanket cylinder. So blanket cylinder, as the name suggests, it is wound with the help of the elastomeric material. So it is a compressible material, and based upon the nature of ink that we are using, whether we are going to use EPDM material or nitrile material, so that will depend on the type of ink that we are using. Only the image part is getting transferred onto the blanket area. So on the blanket we have the image made only with the ink. Once we insert the paper between the blanket and the impression cylinder, what will happen? Under this pressure, this point of contact is known as nick. Under this nick pressure, the ink on the blanket cylinder will get transferred onto the paper, and it will come out and it will dry. So this is especially important because we have talked a little bit about we are going to talk a little bit about the demonstration section also, where we will show some plate preparation process. And these are two methods of plate preparation. One is on the top is known as the positive working plate, and the bottom is the negative working plate. Very simple process. From the name itself, as it suggests, a positive working plate will be made with the help of a positive. There will be a positive film which will be placed on top of that aluminium plate, and it will be exposed from the top. So the non-image areas will be exposed. After development, these areas will be washed up, and only the unexposed, the positive areas, the image areas, that will remain, that will be hardened after development, and that will be inked. But just the reverse happens in a negative working plate. In a negative, when we are exposing the plate using a negative, the image areas are getting exposed, so that will be hardened. Non-image areas will be washed off, and so ink will be applied on the image areas. Then we have the gradual process. As I already mentioned, the gradual is also known as a recess process. As you can see on the left hand side here, this is the gradual, this is the profile cross section of a gradual cylinder. You have multiple cells of varying size and length. So for example, just to draw an analogy here, we explain it a little bit better. In offset, as we saw half two dots are there, that will be of varying size or varying number. In case of gradual, these cells are analogous to those cells. So the cells get the volume, the opening, all can be changed, and all are changed. So based on the size and the volume of the cells, greater quantities of ink will be there, will be inserted into the cells. So wherever the cells are larger, greater volume of ink will be there, and when they transfer onto the paper, greater volume of ink will be transferred onto the paper, meaning that this will be shadow areas, and where there are less volume of cells, less amount of ink will be transferred, that is, there will be highlighted areas. So this way, tonal creation is being created. A very simple process apparently, but however there are a lot of problems there as well for the ink manufacturer. I highlighted you. So there are two parts essentially: the granular cylinder, which may or may not be in direct contact with the ink fountain. It will pick up the ink, and the ink due to capillary action will get inside of these granular cells, and the web or the substrate, whatever you might have, will be made to pass between the granular cylinder and the impression cylinder. Under this pressure and capillary action, the ink will get sucked out of these cells and get transferred onto the substrate. Another important thing is that there is something which is known as a doctor blade, which is written as a blade over here, where all excess ink, because the image areas are in the cells, are in the recess. So on the surface there will be excess ink because the entire cylinder is in contact with the ink fountain. So these are scraped away with the help of a doctor blade. So doctor blade angles and doctor blade structures, these are varying. This will also depend upon the process. So this is essentially a gradual process. Then we have a flexographic printing process. In flexographic printing process, this is just the reverse of the gradual process, which is essentially a relief process, whereby by this I mean relief, I mean the image area is raised. So on the extreme left hand side, this is the ink chamber. This is in contact with a cylinder which is known as the analog cylinder. So analog cylinder is again an elastomeric cylinder which have cells engraved within itself, right? Or threads, you can say, threads engraved within itself. And when they come in contact with the ink chamber, they will pick up ink, and it will transfer this ink onto the flexographic plate cylinder. Similarly, as in offset, where the offset plate was wound around the plate cylinder, flexographic plate is also wound around a plate cylinder, which is the only difference being in case of offset, the cells are the image are normally on the same level, but in case of flexo, the image areas are essentially raised. So the image areas will get inked, and when they get in contact with the substrate in combination with the impression cylinder, the ink will get transferred from the plate onto the substrate. Here, two things are important. One is definitely the analog's volume, the thread count, and how much volume of ink. So, for example, you have a very fine job, maybe a skin tone. You are going to reproduce skin tone, so that will require good precise, contact time, good precise transfer of ink. In that case, analog thread count have to be fine. Otherwise, what will happen if you have a very low frequency analogs? Greater quantity of ink will be transferred. Then all details will be lost. Dot date will happen, all details will be lost. Second point is the angle at which the analogs is actually threaded. This also matters. This will matter when we are working with multicolor printing. Then it will matter. So now we are coming to the ink part, basically, where I want to focus my attention really. In formulation for our printing processes, at least the conventional printing processes, they are dependent on, I think, only one factor: how they are drying. So, for example, if you are working with a conventional offset printing, they are drying mainly using three ways. Based on the way their ink is drying, we can classify the ink into three types. One is quick set, which is normal sheet fed printing. The other is cold set, newspaper printing, and the other is heat set, which is magazine printing. And we are giving the way. But the idea here, what I want to focus is the way it is drying. For quick set, drying occurs in two phases. One is setting and the other is drying, cold drying, right? So the setting part is absorption, quick absorption, right? Low viscosity content, which gets absorbed onto the paper very quickly, immediately within 30 seconds of time, right? If this does not happen, if the setting does not happen, then there will be a problem which is set off. That means when you are stacking piles of paper, one into freshly printed piles of paper, if the setting is not occurred, right, then the back side of the subsequent paper will attract ink from the top side of the preceding paper. So this way of type of offset example is cold set. Cold set is one example of news printing where there is their drying mainly occurs in purification. Oxidative polymerization occurs, but primarily fluid. But there again another problem occurs in newspaper printing, which is known as show through. Also strikes another problem. In both these cases, you must be considering these parameters while printing this, while making the chemistry of these instances, that it should be penetrating because paper newspaper is a porous material. It should be penetrating, but this penetration should not be to that extent. Yes, it will depend on the paper, obviously. But from the ink manufacturer's perspective as well, we should be aware that this show-through strike-through problem does not occur. That is why the way we measure inks on sheet-fed press and on a cold set press are different. So for sheet-fed press, we have what is known as a white bag. So for example, whenever we are using a spectrophotometer to measure, we have a white bag, white sheet on below it. But for newspaper printing, we have a black sheet. Why? Because this problem is shown through. So that backside image does not get captured in the measurement. So this should be, we should be considering. As for heat set is another example of wave printing operation where we have heating process, some form of heating process. So for example, magazine printing on glossy newsprint, while it is high, normally for itself we go for high quality images, high quality jobs. So there what we have is after printing, it will be passed through multiple heating rollers. These heating rollers, the temperature of these heating rollers will have to be raised gradually. Otherwise, the paper may crack because due to hardening, it has to be also reduced gradually. So there you need to use chemicals, you need to use hydrocarbons which are having a little bit lower boiling range in comparison to maybe quick set process, because so that it may evaporate. So their primary drying is evaporation and then setting and all this drying is very possible. In case of flexographic printing also, flexography we have nowadays UVs coming up very rapidly because adoption of labels. In label industry, as you are already aware, lot of press, even in eastern region, lot of people, lot of presses are coming in the form of narrow wave flex. These are UV based flexes, right? So in UV you don't have the problem of slow drying, immediate drying, but there are problems. Chemistry-wise there are problems, but I am saying that in terms of oxidative, in comparison to oxidative polymerization, I saying this problem does not happen normally. But these type of, apart from UV based flexo, we also have water based flexo for food materials. We also have solvent based flexo. These are more conventional processes where other material migration and these things are not to be considered. Then in gravure also, what we have is essentially solvent based. That is evaporation. Evaporation is primary form of drying, and there is no other, because normally what we are printing in gravure is polymeric substance. In flexo also many times, but paper is sometimes also used in flexo. But in gravure primarily we are using polymeric substance, right? So their only way of drying is oxidative polymerization, leaving the resin behind with good addition onto the substance. And normally in case of gravure they are also going for reverse printing, so that the side of printing does not come in contact with the end or contact point. So for example, a chips packet or this tetra packs, all these are using reverse. Now, this I have given a very brief kind of idea that what are the properties and the results that we need to have in various types of things that we will discuss. So for quick set, they are again quick set offsettings are essentially offset your this letter press, screen. These are all examples of non-uniformly fluids, right? So these materials are normally thixotropic in nature. That means whenever we are applying some shear force on them, the viscosity goes down, and after some time it again rises up. So in quick set process, good transfer, as I already mentioned, that good transfer and ink water balance is a key aspect in case of all types of offset printing. Fast setting by penetration and rub and scratch resistant. These are very much important, because normally in quick set process we are printing on monobar. In packaging industry, we are printing on monobar. So for example, maybe a toothpaste package. So they should have very good rub resistance, scratch resistance. Post printing, they should be abrasion resistant. In case of quick set also, we should have the inks which are having good gloss and color spec, and they should be able to run on high speed depths, and they should be heat stable and low mist capability. So by low mist I mean what happens is whenever we are sometimes using pigments which are having high molecular weight, or they are very porous in nature, these inks, normally yellow inks in sheet metal surfaces, they tend to mist, that means fly out of the ink tray. So these problems should be avoided because these are wave normally runs at almost 10 times the speed of, roughly, not 10 times, maybe 7 or 8 times the speed of sheet wave. So it's very high speed process. That should be considered. For cold set, quick absorption, low tag to avoid leaking, and a very good color strength is required. For flexography, correct viscosity is required, and surface tension is also need to be maintained, because the transfer of ink for flexo is not direct but with the help of analog roller. So the nature, as I already mentioned, nature of analog roller, the structure of analog roller is important, but at the same time the ink chemistry is also important. For durability, very fast drying, and for durability another very important aspect is addition of the resin system onto the substrate. This is very, because there is no other form of drying apart from evaporation. If the volatile component is evaporated, we are only left with the solid resinous component. So that should adhere onto the substrate very nicely. Again, some key print quality aspects for quickset. Normally quickset we need higher gloss in comparison to cold set. For flexography, we should be having the ink should be having the ability to form flexible films and should be abrasion resistant. For granular inks also, they should have high strength, smooth lay, and in certain cases solvent resistance. These are some of the methods for testing various parameters of testing various metrics for inks. For example, viscosity we have various flow cups, rotational viscometers. For tag we have tag meters, incometers. Flow we have for isotropic material testing, non-union nature testing we have cone and plate viscometry. For color related measurements we have spectrophotometric measurements, gloss we have gloss meters. Drying we have various set of types. One example is with the help of proof bound testers, rough resistance, Sutherland rough testers, abrasion testers. Addition is one very common example of testing addition is tape test. So we take specific addition type tape and then we peel it off at various angles depending upon what we are taking and what is the end use. We peel it off. Emulsification test is only required for offset process printing. pH is required also. Surface tension is normally measured both for inks as well as coatings, mainly for coatings actually. In the polymeric substrates, there we have dyeing testers, whereby essentially we should also be always be thinking of this term that the surface tension of the material on which we are making should be higher, so that contact actually is sufficient to capture or adhere the ink properly on the surface. Then we have penetration testing, misting tendency testing, light fast testing using blue scale. Earlier we used to have blue scale, and now xenon testers are there. Chemical solvency tests and foldability and other sorts of tests. So now coming to the last part of the lecture, yes, we have time. So this is the quality control part. This is I'll start with a little bit about densitometry. Densitometry is a study of density. So density is not to be confused with density of materials, but this is optical density, right? Whereby we essentially say that the density of the sample with a 100% dot is higher than the density of the object with a 20% dot. So this is measured with the help of a densitometer. This is a light source, certain optical devices. We have polarizing filters and color filters as well. This is the sample whose density we need to measure. Some amount of light is getting reflected at specific geometries. It is being captured and it is the value is red. Normally, what density mathematically is the negative logarithm of reflectance, reciprocal of reflectance. What happens is density is kind of comparison. If you take a white sheet of paper and if you take a black print on the same sheet, which is going to reflect light less, the black quantity has a black print. So higher the quantity of light that is being reflected from a surface, lower is the density, and lower the amount of light that is reflected, higher is the density. Why this is required? So this is required for process control. So for for example, as you can see that chart that I have given here, this is known as tone response curve. What normally what happens is whenever we are printing using outcomes or this type of chemicals, these are essentially having some tone values, maybe 10%, 20%. So a linear scale is the ideal response. That means in the input we have 10% tone, then in the output we have 10%. But due to dot gain, it is bound to increase. Dot gain happens due to optical reasons, in the plate preparation, film preparation, or it can happen at the press. There is no way to eliminate dot gain. We can control dot gain, right? So this controlled tiers has to be maintained. There are certain mechanisms using which we can control this. That is why this is known as, there is a formula which is known as Moore-Davis equation, using which we can, from density values, we can calculate the dot gain and the fractional dot area. From that we can actually counterbalance the effect of dot gain. So that is why density is very much required. The second component which is most essential nowadays is the color. Now color is a very complex a psychophysical parameter whereby we perceive color due to the presence of LMS cones in our eyes. But mechanically or computationally, we can also obtain some color values. These are normally known as tristubular values. These are imagined. These are also sometimes known as imaginary primaries because they don't physically exist, but they are mathematical concepts which are able to, using which we can able to numerically quantify colors and communicate colors very precisely. The key takeaway from this discussion here is that color is so complex. And you see there are three displays in front of you. The same image I am showing. These three displays are showing it different. On my computer here it is being shown different. So how do I quantify color? Manufacturers as well as for the press. For manufacturers to follow this standard, for press to comply, and while buying, procuring the inks, to ensure that they have the inks are having this particular values. Next, this is more of a press oriented standard. This is known as ISO 3664, which is known as viewing definition. So, for example, nowadays the use of hard copy originals are almost obsolete. Nowadays everything is set digital. So maybe my press has a FTP slot as a transfer digitally, and I am making a proof. Proofing machines are normally inkjet based machines, but I am going to, for production printing, I am going to print easily graphic or print using maybe offset. Then these two should match. That is, my proof and the print should be the original. This is easier said than done. So matching part is what this standard is saying, that how you should match it. What is the view should match it? As in the bottom here, this is, we have a viewing chamber. We have recently developed this in our institute also. This is the viewing chamber, and this is the monitor. This is the calibrated monitor that we are having. This is a hard copy proof, and this is a soft proof, right? Both of them should match, and that condition, what illumination has to be used, what is the CI correlate, what are the illuminance conditions, all these conditions are given in this standard, so that under these conditions you are going to match your hard and soft proof. All this is done essentially to meet the expectation of the client. So otherwise this is a very costly effect. Let's say you are getting for packaging printers, maybe TCPL or Pulsar, whatever. They are going for repeat jobs. Maybe Colgate commonly have given them a job of 1 or 2 lakh copies of monocopies. And without going for all these steps, they have gone for production printing. And when they have sent their product to the end user, the original is not matching with whatever they have sent. So they apply a lot of risk. So that is why it is most essential that these standards be adopted by manufacturers, production printers, and end buyers, all of them. The next standard, which is known as the spectral measurement condition, is 13655. They are giving the conditions under which that particular color values, those particular density values are to be measured. There are 4 conditions, 5 conditions basically, but we classify them into 4. M0 is the legacy standard. Earlier we used to have incandescent sources of light. Then nowadays we have the de facto standard, which is D50, that is illuminated. Normally these tube lights are having, these are uncolored, but they are having color temperature of 5500 Kelvin. So for print processes, normally for polish control, we are having normally this illuminant is 5000 Kelvin. So that is the de facto standard. This is the CIE opinion defect. This is simulating daylight, normal daylight. But the problem is, you see, all these standards are made in Europe. This daylight is also European daylight. Nowadays we have D65, 6500 Kelvin. That is also in northern hemisphere daylight. Here daylight is different. There daylight is different. That is how it works. But nonetheless, that is the condition M1. In M1 we have a specific condition that is to be made, which is part 1 and part 2 for OBS. This is very essential for ink manufacturers and paper manufacturers also, because for increasing brightness of the compound, I mean for the product, we normally use optical brightnesses or fluorescent. But the problem with this, using this, you see, is that these are the absorption filter. The problem with OBS is this OBS will absorb light in the invisible range, that is below 400 nanometer, ultraviolet range, right? But when reflecting, we would have thought that they are also reflecting at that range, so that will not matter to our, because we are measuring from 400 to 700 visible range nanometers. But while reflecting, this OBS and FAs, they are actually reflecting above 400 nanometers. So that will come into our measurements, and that will create problem for measurement. That is why this particular condition states that we have to use M1 condition in part 1. When both ink and paper they have OBs, and only if paper has OBA, then part 2 has to be used. M2 condition is known as UV cut. So this eliminates this problem altogether. You don't have any UV material and UV illuminant, UV component in your illuminant. Then the OBA does not have anything to absorb. So no question of reflecting. And M3 is polarizing filter. Polarizing filter is a specific type of condition where we are. So for example, if you have seen some places they are printing ATM cards or this type of jobs. Normally after printing, they are giving a overprint varnish or a lamination coating. After some time, this is a common observation with our mobile phones also. After using it, sometimes they oxidize and they change the colors. They yellowish tint happens. So in those conditions, we need to know precise measurements before and after overprint varnishes are done. So in those situations, we have to use M3 condition using polarizing filter. And the final, this is the most important standard, which is the 1 to 6 process. This is a set of 8 standards. This 1 to 6 process, part 1 to part 8. This is part 2. This is for process control in sheet-fed optical lithography. Part 3 is on fluorescent lithography. Part 4 and part 5 is there. What this standard is saying is, and if you take a look at the figure 25 here at the bottom, this is what is known as a process control wedge. Normally when we are going for production printing, just below the page, we are going to print these types of wedges. And then after printing, for process control purpose, we are going to measure various values. We are going to measure density, we are going to measure tonal value, this dot game, we are going to measure LED of all this. What is the purpose? Purpose is that we need to ensure that these values are within this particular range so that we are meeting a particular standard. A set of paper, plate, printing process, don't have ink, these 4 or 5 combinations together, they are known as reference print condition. So for example, why this is important to my class? I have a press which is having a paper maybe 120 GSM, 95 white space. I have another press, maybe this press I will, but I have another press where I am printing on 200 GSM board for different purpose. Whiteness normally for board is lesser than paper. Then maybe I have 85 or 90 whiteness. In a particular case, it may so happen for primary and secondary packaging, both the paper and board have to be printed with the same image. Then I need to ensure that the output quality, that is the color, the every other aspect, is everything, is same or similar. Even if not same, then similar for both the things. What should be the benchmark that I should follow to ensure that it is same for this type of process control parameters? So this is a very important standard which is getting adopted into the industry. So with this, I come to the end of my presentation here. Thank you for your attention. I would welcome any questions that you might have on the presentation. What you mean?
Yes, just one thing I just want to ask you that you told that regarding the density variation on after treatment during the treatment process.
Yes, yes.
So is there any permissibility for
Yes, that permissibility is given in this 1 to 6%. You see this TPI that we have. This is initially I told you this actually. Thank you for doing that. These are the TPI costs. 30 students they know they follow. This is not known value index. This is the same as the TRC only. This is one dot gain parameter. There are 5 cards. Here it is. I don't know what happened, but here there are 4 cards. No, 5. Yes. A, B, C, D. These 4 cards, they are talking about the TVI, that is how much dot gain is permissible for a particular reference paper. Because there is common observation. On coated paper, dot gain will be less, on uncoated paper it will be high. So I cannot expect that in coated paper I will also have the same, in uncoated paper also same dot gain. It will be high. Then for this AM screening we have these 4 things, and for non-periodic FM screening, as I already told you, highest. This is the highest. So these are the permissible. Anything else? Yes, sir.
My observation, there is a tornado of technology, I think. What not is there? From very beginning, dot modulation, you hear frequency modulation, then capillarity, viscosity, surface tension, so and then. So when we are engaged in any work, we are observing the output, then we are keeping in mind the science. If this is the output, then beyond this, what should be the science? So I think this is a good partnership program. What is going on today, this is a good partnership program. And sir, I am requesting you, we are ready to give any consultant in future if you think, and also and give and take opportunity.
Thank you for your attention, everyone. And now we are very much interested to hear from the experts in chemistry who are here